Stan Gibelisco here, proprietor and operator of Mobile CW amateur radio station W1GV Whiskey 1 Golf Victor. Actually now, I know that it's capable of functioning all the way from 80 meters all the way through 70 centimeters. I actually got this Palstar antenna tuner, which you are looking right now at the cross needle meter of that tuner. The FT857D is tuned to 7.035 megahertz with the active tuning antenna system from Yaesu. Now I'll show you how that works. It's really kind of nifty. It's tuned on this frequency right now, so if I hit tune, it isn't going to need to do anything. But let's suppose that we want to change bands and go up to 30 meters. Now I need to retune that antenna again. You hit this little tune button on the radio. I'm not showing the radio here, but instead I'm going to show you what happens when I hit this button. There, it's tuning. It's sending out a carrier, in this Yaesu active tuning antenna system is mechanically sliding down and getting shorter. Now watch! It's tuned now. Now if I send a carrier on here, .30 watts forward, I've adjusted this RF power output to 30 watts and 2 watts reflected approximately. The frequency right now is 10.11475 megahertz. Now this active tuning antenna system will not function below 7 megahertz, as far as I know. I tried it on 80 meters and it simply refused to do anything. Now we're up to 14.02433 megahertz. I don't want to interfere with anyone. 14.02073. Let's tune it up now on this frequency. Notice now that we get a lower forward power reading until the thing finally finds the frequency. Once it finds the frequency, if you hit tune again, it just doesn't stay on because it's already where it needs to be. .30 watts forward, 1 watt reflected. Now let's go back down to 40 meters. I'm skeptical as to whether an antenna this short will work on 40 meters. But let's just go back down to 7.035 and hit tune again. Now notice that it's got a really rotten standing wave ratio. It's the one thing about this radio, this FT857D, it's so easy to hit buttons you don't want to hit. Bristling with buttons. That seems to be the paradigm or the hallmark of modern electronic devices. They're bristling with buttons, and you push them when you don't want to push them. See, now I've hit that tune thing again, and it tunes rapidly. I've got to hit the power switch briefly to get it to tune slow again. That's the FT857D. But now that SWR is essentially 1-to-1. 30 watts forward, 1 watt reflected. The antenna is about 5 feet long altogether. And so if we have a perfect SWR with an antenna 5 feet long, we can actually look up the radiation resistance of that element, which is simply a function of its length in free space. And then we can calculate the loss resistance, because the loss resistance in the system plus the radiation resistance must equal 50 ohms because we have a 1-to-1 SWR. So we can just use a little algebra and figure out, I'll bet this thing isn't very efficient. But if I'm putting out 30 watts and I'm only getting, say, 10 watts out into the atmosphere, into the ether. We're still doing all right. We can still make contacts. Now, the other thing, I can switch this Palstar, and you aren't going to be able to see that switch, but it's directed coax 2 right now, which is the active tuning antenna system. Now I have it on tuned coax 1, which is the 8-foot whip, and by tuned, it means it goes through the Palstar Transmatch, and so hopefully well, yeah, you see, we are getting a pretty close to 1-to-1 SWR. I pre-tuned that. Now, what I'm going to do is I'm going to look for a contact that wants to chew the rag a little bit, and then I'm going to switch back and forth between these antennas and ask them to compare the 5-foot-long active tuning antenna system by Yaesu versus the 8-foot-long force-fed coax cable 8-foot whip with a transmatch at the transmitter end of the feed line, so I'm force-feeding that line. There are going to be loss in the line with this system, a lot more than there is with the Yaesu, but I assume there will be less loss at the radiating element. Notice how much quieter on receive this antenna is, this 8-foot whip. It has a high SWR on the feed line, but not at the transmitter. This Yaesu, and I've switched back to it now, the active tuning antenna system. That antenna system has that's the actual standing wave ratio at the feed point of the antenna, so there's very little loss in the feed line. But there's going to be more loss from the radiating element because of the radiation resistance, which will be lower for a 5-foot antenna than for an 8-foot antenna. But the proof of the pudding is in the eating, and we're going to find out what's really what. Now, the reason why it's quieter on receive in this other antenna, even though the SWRs are the same at the radio, and so they're both tuned to resonance, is rather esoteric and complicated, but a mismatched antenna at the feed point will produce poorer reception than a well-matched antenna at the feed point, even if you've got a 1-to-1 SWR at the radio in both cases. Someday I'll do a little technical video explaining why that is. So the fact that this antenna, S8 noise right now with the Yaesu active tuning antenna system, S7 noise, it's still pretty loud. Wonder if I've got the RF gain goofed up again. Yeah, I sure do. I sure do. Okay, S0 on the 8-foot whip, almost S8, S9 on the Yaesu. But that doesn't mean a whole lot, and there are technical reasons for that. See my fist reflected in the window? I'm emphasizing this point. Weird things happen in these videos, I'm telling you. But I'm doing the best I can. Maybe something weirder. I'm not going to burden you with a rag chew video, but I will tell you the results when and if I actually get them. And I'm going to try this on 40 meters because these antennas are so short physically on this band. It ought to be a real challenge with 30 watts to see what I can do sitting in my driveway or the parking lot of some store. Well, I've yammered at you long enough, but I hope you've gotten a little informative stuff out of this video. More to come later. 73 from W1, Good Vibrations in the Black Hills of South Dakota. For now, so long.